Hello, I'm Sean Barr, and with me is Ed Wright. We're with the Austin Company. The Austin Company is a design and construction firm in food and beverage and other various industries. I wanted to talk to you today about conceptual planning. My background, I had 20 years in manufacturing and food prior to joining the Austin Company a little over 14 years ago. Came up through engineering and project management and now lead market sectors for the Austin Company. Ed Wright is a food scientist, an animal scientist. He ran plants for about 25 years prior to coming over working with design and construction. Ed and I lead market sectors in meat and poultry and related industries for the Austin Company. So today, I wanted to talk to you about conceptual planning. That's one of the first things that we typically start with a client. I'm going to share my screen for a moment. So what is conceptual planning? Conceptual plan is an overview of a new or expanded business venture. It can be used to expand on an initial business idea, guide more detailed planning, and communicate essential information. This study helps validate and organize the customer's visions to meet growth requirements. And when do we need to employ a conceptual planning study? If you have new or expanded product lines, cannot meet sales demand, excessive downtime, low productivity, consideration of a new or expanded facility due to excessive building age, new or more stringent food safety requirements are a few of the items that might drive a client to want to execute a conceptual planning study. So where does the conceptual plan fall into the overall design build methodology? On this graph here, we see on the step one, we have conceptual design. This is the first step that we work with our clients to help identify what they need to do to meet their demands or address their issues. And then once the conceptual planning study is complete and everyone agrees that the parameters are correct and we're executing what needs to be done for the company, we can proceed into preliminary engineering with a detailed cost estimate, go through construction documents, procurement, and construction. So the conceptual design, the conceptual planning study is the initial phase to understanding what needs to be done and helping clients meet their needs going forward. Some of the key parameters that we need to discuss before we actually get into the conceptual planning effort is develop parameters for success. A few examples of these could be employee safety, food safety, manufacturing flexibility requirements. We need to understand the needs and the drivers for the project. Is there a schedule constraint, a date we must be operational to meet some sales expectations? Are there cost constraints from a financial standpoint? Are there product deliveries to support marketing initiatives, or just a few examples? We need to agree on the products and processes. We want to understand the product characteristics so we can make sure that we're utilizing the correct processing equipment, and we need to understand the packaging requirements so we can deliver the product as the customer requires. And we need to collaboratively establish volume demands so we have a target on what we're trying to meet. So one thing we're going to do here, this is an example conceptual planning report. Once we've gone through all those other preliminary information and understanding, then we go through these different aspects of a conceptual plan and then come up with a report. So this is an example of what you might see. We're going to have an executive summary, constraints analysis, conceptual layout, room criteria matrix, building and building systems narrative description, a process narrative, equipment list, a milestone schedule, and an order of magnitude estimate. Now, depending on the project, all of these projects are typically custom. Some of them require in-depth analysis in each one of these areas. For the use of this discussion, we've shortened it dramatically. So we may have an example in here that is 1 or 2 pages where in reality, in a real study, it could be 20, 30, 40 pages. But we just wanted to give an example here so you know what you might be looking for. So in the executive summary, we're really just kind of reviewing the background and objectives of the project to make sure that our understanding is proper and going to meet the objectives of our clients. the methodology we're going to go through, and then a summary. On this particular summary, we had the square feet required for each of some of the areas, and then occasionally we'll put in the dollars, cost estimate, and things of that nature, depending on the objective of the particular study. Now, one of the first things we do when we engage with the client is we want to make sure we understand, as I mentioned before, the annual volume requirements and the product characteristics, so we can start working through what equipment is going to be required. One of the things we do to identify the required equipment is do a constraint analysis. Now, constraint analysis, this is an example. We want to outline the general assumptions. So we're looking at how many pounds per year of a product are we looking for. Then we kind of break that down to pounds per day. We're looking at the raw weight of the product, green to finish yield, and the general parameters that are going to carry you through the study is what we want to identify in the general assumptions. Then we want to, based on the annual volume and the requirement of days of storage, we're going to look at how many pallet spaces do we need in raw receiving, so we can properly size the raw receiving cooler. Then once we get into the process, we look at every piece of equipment that's in the process. This particular one is a ham process. So we're looking at brine mixing for the injectors. We're looking at the injectors, tumblers, drench cabinet. Now we're looking at each piece of equipment independently to determine what the capacity is. And then as we do that, we go through this smokehouses, blast cells, and then packaging lines. And then on the finished goods, again, we determine how many pallet spaces are required based on the assumptions. And then we bring all that into a recap. We identify the capacity constraint, and then we can annualize the volume to see if we're meeting the expectations or not. Now, we've done a different presentation on this, so on the capacity constraint analysis. So we'll not go into a lot of detail here. Just wanted to say that is one of the first items that we go into that helps us identify, based on the product characteristics and annualized volumes, what equipment's required and the sizing of the equipment to make sure that we meet the annualized volumes that are required for cells. Now, next we go into a conceptual layout. Ed, would you like to walk through that?
Sure, thank you, Sean. When we do a conceptual layout, what we do is we take the information that's derived from the constraint worksheet, and it tells us how many pieces of equipment, what kind of equipment do we need to produce a layout that best meets your expansion requirements. Now, one of the things we do is we do the layout of the process first and foremost. In other words, we lay out the process to optimize equipment efficiencies, to minimize employee interaction, and to maximize profit and throughput. When we agree to the process parameters, we then collaboratively determine what type of equipment we'd like to use. We look at how much automation we want to use, and how much automation can we afford to use. Then we look at employee access. How do we minimize their walking, maximize the ease? We look at food safety, how to maximize food safety in this advent of FSMA. We all have to be very careful with our food safety design. Once we get all that put together, we put in the ancillary pieces of the plant. That would be the incoming raw material coolers, incoming dry goods and packaging supplies, finished goods, coolers, and then the building support areas. We would also then work with our client and collaboratively determine the staffing for the facility. When we determine the staffing, then we could put together the employee welfare areas. We can make sure that we have the proper access to raw and cooked to segregate those employees. And we could add whatever the required support offices would be for each individual customer. Once we have that layout complete, we know what the ideal plant looks like to meet our processing needs. Then what we do is we make a sketch of the plant, and we can apply that to any commercial site search. If we're making a greenfield, we take that outline, place it on a site to make sure that it fits, to make sure that there's nothing that encumbers our working plant on the site. For example, wetlands, streams, things like that we would have to build around. And then we would also have the utility requirements for the site. So once we find a site, we can put it right on the existing site. We would take a Google Earth map, take a picture of the site, put our building on it, and here we can see, oh, we have a low spot that's a wetlands right in the middle of our site. Now, can we build around that? Can we have the wetlands somewhere else? That'd be something we could figure out. But in this instance, it quickly shows us where this site may not be the ideal solution. After we get all that done, in your report, you will get a room criteria matrix. That matrix will tell you all the fits, finishes, and environmental conditions in each room in your facility. That way there's no misunderstanding of what you're getting. Each room will have a square footage. We will tell you the clear height in the area, the design room temperature, whether or not it's that design temperature will be accomplished by heating and ventilation and air conditioning, or if it's a refrigerated room. We would tell you the floor finishes, what the material is. Generally, it's concrete. Sometimes it's different. Finishes can be a urethane floor. It could be tile. It could be sealed concrete. Whether or not there are curbs in the room, the description of the height of the curbs, whether we require a cove base, and then all the walls. Each of the ordinal directions in the room, north, south, east, and west, will be described as to what the wall is made of and what the external finish is. And the same thing will happen with the ceiling. We will tell you the material of construction and what the finish is. We'll delineate drains, what type of drains, what slope on the drains, and we will also delineate a sanitation code, which gives all of us, especially the engineers, the understanding of what type of washdown will it require in that room. So the engineers know if it's total washdown, if it's just broom swept, so that they know what standards to use on the electrical and conduit in the room. And also there will be a key for each of these areas that is included with the room criteria matrix.
Thank you, Ed. Going along with the layout that Ed described in the room criteria matrix, we have a section for building and building systems narrative. descriptions. So that's when we have everything on paper on the drawing, but then we want to describe in words what you're looking at to make sure we're all on the same page. Now, this is a very condensed version we're about to take a look at. Typically, you have all the divisional breakdowns and detailed descriptions that go along with that that correlate to the drawings. What we're going to look at is just the first section, which is Division 1. And it goes into detail the summary of the work, testing, laboratory services, construction facilities, supervision. It goes through and describes in words and in detail what we're trying to do and convey with the layouts, the drawings, the room criteria matrix, and other aspects of the project. So this is a very high level overview of what is included in that. This is a 4 or 5 pages, and typically these can the narratives, depending on the size and complexity of the project, can be dozens or over 100 pages. But this is an example of what you might see that you can read along to make sure that the deliverables are being met. And also, we have our process narrative, which is a similar approach where we're looking at telling what we're trying to do, what we're trying to accomplish, the products that are being manufactured, and then we're kind of in words explaining what's going on, what equipment's going to be utilized. So the process narrative coincides with the layout, with the equipment, and things of that nature. Now, the equipment list is an extremely important portion of the conceptual plan. On the equipment list, there's an example. We have it's typically an Excel spreadsheet where we're looking at each room in the facility. We're identifying what equipment is in that room. If you have a chosen vendor, that we can identify them as well, or if there's 2 or 3 that you're looking at, we can identify those. Look at model numbers of the exact equipment, and then we kind of go through and we want to identify what utilities are required. So from that, we go into electrical. We're looking at the kilowatts, horsepower, voltage, phase, etc. of the electrical equipment is all identified. Then we go into steam, all utility requirements, whether it's steam, refrigeration, looking at compressed air, is it natural gas? So as we go, we start this in conceptual plan and we fill it out in more and more detail as we go through the engineering process. But this is a starting point. So we identify all the utilities that are required for each piece of equipment. And then we also take that and extrapolate it to the unit cost. If we've received proposals, we can color code this. If we've got a hard number from an equipment vendor, or if we're putting an estimate in based on our experience, so we can understand the level of confidence we have in these unit costs. We add in what we think the freight cost is going to be, an installation cost, and then extended capital costs. So at the end of this study, we can go through the utilities and the cost and add up to see what's the total usage required. So we'll have total electrical for the building. And obviously, electrical engineers will take that, put a safety factor on it, and design the major systems. All the other disciplines will do the same, and we'll have an idea of what we think it's going to take to buy and transport and install all the processing equipment. So this, in conjunction with the detail or the cost estimate, which we're about to get to, can give us an idea of the overall cost of the project. So again, this is a very short example. These equipment lists can easily get 50, 60 pages or more, depending on the size and complexity of the project. Now, once we have all that information done, we put together a milestone schedule. So we're looking at the building systems and process equipment, and starting at the end of the conceptual plan, when we're released on continuing engineering, we track all of that and then go through the entire design and construction, installation, and startup process. So it's not a detailed estimate at this point, it's a milestone, but it gives us a good idea of the overall duration of the project so we can see if that meets the expectations. If it doesn't, then we can work through alternatives to see what we can do to speed things up. Then based on that, based on all the above, We put together an order of magnitude estimate. Now, typically on a conceptual planning study, this is going to be done within a few weeks, a couple of months, and the estimate is going to be reflective of that level of effort. So we're going to come in probably the 20 plus or minus 25% on a cost estimate at this level, 25, 30%. And then as we go into more and more detail, then we'll be able to refine that and get a tighter number. But this gives us an idea if we're headed in the right direction on the cost or not, if we're meeting our hurdle rates. And let's see, there we go. So it's a divisional breakdown, which is a traditional approach for design and construction. We're looking at general requirements, site work, concrete, masonry, metals, woods and plastic, etc., through the different divisions of construction. And then we come through and then apply some overhead GAC fee based on the total cost. And then we get a total grand cost of the project, and then extrapolate that out based on cost per square foot. And we have percentages of the overall cost by division, things of that nature. So we have a good idea at this point of the cost, the schedule, the parameters of the conceptual planning study. We've identified the capacities, we've identified the layout, the square footage requirements, the acreage requirements for site in case we're doing site selection. We've covered the major aspects of the design build process for a particular project. So then we present this back to our clients, and obviously we've worked collaboratively throughout the process, so we're all on the same page. And then they can see to make sure that it's meeting the expectations or requirements to meet their business needs. So this is a high level study, but it gets into some really good parameters for our clients to understand how they're going to have to finance and operate and run the building and the process. Thank you for your time. Appreciate your interest in our conceptual planning approach. If you have any questions, there's contact information. Please reach out. We'll be happy to talk to you about your particular application or answer questions about our process. Again, thank you for your time.